Assalamu alaikum. This is fourth part while solving the May-June 2024 paper 1 variant 1 of further mathematics. In this video we are going to solve the fourth question of this paper, and the fourth question is of the chapter matrices. Okay, so let's read the question. The matrix M is given by this and this. Wait here. Okay, so this is our matrix. The matrix M represents a sequence of two geometrical transformations in the xy plane. Give full details of each transformation and make clear the order in which they are applied. Okay, so we have to give description, give full details of the transformation. This is a stretch. This is a stretch in x-axis. Let me tell you how can we get it, that is it a stretch for x-axis or y-axis. If it is like this, we can memorize it through cool. This is k, this is 0, this is 0, this is 1. Okay, this k is the scale factor or stretch factor. Okay, while in y-axis, if the stretch is in y-axis, our bracket will be like, wait for a bit, our bracket will be look, this is 1, this is 0, this is 0, and this is k. The k is the scale factor or a stretch factor, not sketch factor. Okay, so, and one more I want to tell, when it mentions make clear the order, and we have two geometrical transformations. It mentioned here two geometrical transformation. So while giving detail, we will write the second one first, and then we will describe second one. Then we will describe that first one as a second. Okay, so first here we discuss that stretch in x-axis, because the scale factor k is written at the first, not at the end. I hope you get this. So how I will write it? I will write it as one way stretch parallel to x-axis with scale factor equal to 14. Okay, we had discussed all these things, stretch in x-axis and scale factor. Okay, then before writing the second transformation, we will write followed by. It is compulsory to write followed by. Okay, first we write this transformation, then we write followed by, and now we will write this transformation. Okay, so let me tell you, there are two types of rotation. First is anti-clockwise rotation. In anti-clockwise rotation, our bracket is like cos theta minus sine theta and cos theta. If we notice, this and this will be same, okay, and this and this will be same, but there will be the negative sign. I hope you get this. While if I talk about clockwise rotation, the clockwise rotation is like I want a space. Let's okay, I will do like this. Clockwise rotation, there is cos theta, sine theta, and here is negative sine theta, and here is cos theta, and this bracket get closed. So what is the difference? How can we discriminate the anti-clockwise rotation and clockwise rotation? We can discriminate if the negative sign is here, it is clockwise rotation, sorry, then it is anti-clockwise rotation. If the negative sign is here, it is clockwise rotation. I hope you get my point. So in this bracket, if we look at this, they both are same, okay, and if we look at this, the values are also same here, but the sign is negative here, which tells us that it is anti-clockwise rotation. In an anti-clockwise rotation, the negative sign is here, and if we look at this, the negative sign is here, not here, okay. Then we want one more thing, theta. How can we find theta? We had discussed that cos theta equal to 1 upon 2. If we compare our general form and this bracket, so we get that cos theta equal to 1 upon 2. So if we calculate it using the calculator, it's your choice to do in the degree or in the radians. I am doing this in the radians. You can do in whatever mode what you want, it is upon you. So the theta is 1 upon 3 pi. Okay, so our first part will be done, followed by anti-clockwise rotation, of angle 1 upon 3 pi about the origin. Let me tell you what are important things to write in our answer. We have to write one way stretch. This is important thing in our answer. Then parallel to x-axis, and then scale factor. Then this followed by is compulsory, okay, along, and then we have to write anti-clockwise rotation of angle 1 upon 3 pi about the origin. Yes, so this is our keywords which we have to write in our exam. If you want the clean and neat solution, you can go into the description, there will be link, paste it for the drive. You can go to the drive and you can access the solved past paper. Till this paper has been solved and uploaded on that folder, so you can go and visit and can get the clean and neat solution. While explaining, I make too much. I write, I write, and I don't do neat and tidy work because my target is here to explain the concept. Okay. Then our part B is write M inverse as the product of two matrices. Okay. Neither of which is index. Okay. I means index. Product of two matrices. It means, let me rub that. Yeah, I want to rub this. Okay. When it says product of two matrices, we will write inverse M inverse as, let's say this is A and this is B. M inverse will be equal to B inverse and A inverse. First we will write the inverse of this. Wait for a bit. Then we will write the inverse of this. Okay. So before that, if you know how to take out inverse, I will tell you in detail. To find out inverse, we want determinant. So first I am finding out determinant of A and B both. Determinant of A. How we will find determinant? We find determinant, multiply this 1 upon 2 and 1 upon 2. I will show you how we will find out determinant. Then 1 upon 2 by 1 upon 2. Then minus. Then we will multiply this. Minus 1 upon 2 under root 3. And minus 1 upon 2 under root 3. I want you to do this in calculator and to confirm that the answer which I am getting is correct or not. So I got wrong. Wait for a bit. So the answer we get for determinant A is 1. Okay. Now we want determinant B. I want to find out the determinant B before me. Determinant B we will get by 14 by 1 minus 0 by 0. So it will be 14. So these two determinants will be used while finding the A inverse and B inverse. First I am finding out the B inverse. So we will write here bracket open. And how we will find inverse? Let me tell you. What we will do? That's the question. Okay. First we are going to find out B inverse. So it is, let me write, B is equal to 14 0 0 1. Okay. When we are going to find B inverse, we will shift this 14 at the place of 1 and we will shift 1 to the place of 14 and we will change the sign of these two, but in this condition they are 0, so don't need to change the sign. So if we swap 14 and 1, here will be 1, here will be 14 and here will be 0 and 0. I hope you get this. Okay, we will swap the positions of these two. There was 14, we write 14 here, and there was 1, we write here 1 is here. I hope you get this. And then we will divide it by determinant of b. What is determinant of b? Determinant of b is 14. So we get b inverse as 1 divided by 14, 0 divided by 14, 0, 0 divided by 14, 0, and 14 divided by 14 as 1. This is our b inverse. Then we will find a inverse. To find a inverse, what I said, that we will shift this to this position. If we notice they both are same, so just write 1 upon 2 and 1 upon 2. And the sign of this will be moved to this. So it will be negative 1 upon 2 under root 3, and there is 1 upon 2 under root 3. Okay, and this will get divided by 1, which is determinant of a. So it means it will be 1 upon 2, then here 1 upon 2 under root 3, we had shift the sign. Here is negative 1 upon 2 under root 3, and here is 1 upon 2. Okay, so how we will write M inverse? We will write M inverse as B inverse first. What we get B inverse? We get B inverse 1 upon 14, 0, 0, 1. Then we will write A inverse. Our A inverse is 1 upon 2, then 1 upon 2 under root 3, then minus 1 upon 2 under root 3, and 1 upon 2 here. So that's our solution for part B. Okay, now we are moving to this part C. Okay, so part C we will do now. In part C, the question is saying find the equations of the invariant lines through the origin of the transformation represented by M. So these three things are important. Equation of invariant lines. Invariant lines are basically straight lines. So it is y equal to mx plus c. Then the question says through the origin. When it passes through the origin, this becomes 0. So our equation will be y equal to mx. Okay. Then we will do that. We say that x is equal, if x equal to t. Okay. If, let me write it in the next line, if x equal to t, then what will be y? We have this equation. If we write mt, so this is y. Y is equal to mt. We got our coordinate. So our coordinate is t comma mt. Okay. We have this. We have this. Okay. We just wanted y is equal to mx to find out y. So the thing which we will use is this t comma mt. Okay. Then the question says represented by m. So we want to find m, but you will say the m is given in the question. The m is given, no doubt, but the m is given as a product form, and we want as a one bracket. So we will multiply both of them. So how we will multiply matrices? 1 upon 2 will get multiplied by 14. We will get 7 here. 1 upon 2 multiplied by 14. Then we will multiply negative 1 upon 2 under root 3 multiplied by 0. We will get 0. Okay. Then what we will do? Let me rub. Oh, one second. Now what we will do? Now I will multiply 1 upon 2 with 0. It becomes 0. And then I will multiply negative 1 upon 2 under root 3 with 1. So I get negative 1 upon 2 under root 3 here. Now I will multiply, wait for a bit, yeah, I will multiply 1 upon 2 under root 3 with 14. So I will get 7 under root 3, and then I will multiply by 1 upon 2 by 0. It becomes 0. So I will get 7 under root 3 here. Now I will multiply 1 upon 2 under root 3 with 0. It becomes 0. Then 1 upon 2 by 1, and it becomes 1 upon 2. If you didn't understand this, so here you need to do matrices, and inshallah within few months the videos for matrices will also be available on my channel. Okay, so this is m. Now what we will do? This m and t comma mt will be used. I will write 7 negative 1 upon 2 under root 3, 7 under root 3, and 1 upon 2 multiply by tmt. So now what we will do? We will multiply both of them, and we will write here. This 7 will get multiplied by t, and this will get multiplied by mt. So we will get 7t, and negative 1 upon 2 under root 3 multiplied by mt becomes negative 1 upon 2 under root 3 mt. Then we will multiply 7 under root 3 with t and 1 upon 2 with mt. So we will get 7 under root 3t and plus 1 upon 2 mt. Okay till this? Now we will use this. Yes, now we will use this. We have general for y equal to mx. This is x and this is y. So let's write y at the left side. 7 under root 3 t plus 1 upon 2 mt equal to m, and multiplied with x means 7t minus 1 upon 2 under root 3 mt. Okay, so now I will get 7 under root 3t plus 1 upon 2 mt equal to 7 mt minus 1 upon 2 under root 3 m square t. If we notice the t is common with all terms, so we will cancel this t. These all t's are got cancelled. Now we can get our quadratic equation. Before that, no, I want that the equation should be fractionless. So I took 2 as LCM, so here it becomes 14 under root 3 and then plus m equal to 14m and minus under root 3 m square. I multiplied the 2 with the complete equation, and when I multiplied 2 with this, so this 2 and this 2 got cancelled. Then same with this, then when I multiplied with this 2 and this 2 got cancelled. Now I can write as ax square plus bx plus c. I will shift under root 3m square to left. As it was negative, it become positive now. There was 14m, and when I will shift 14m to the left, it become negative 14m, and there is plus 3m, so it become negative 13m and plus 14 under root 3. Let's do it from calculator. Instead of factorizing it, we can do it through calculator. That under root 3 equal to negative 13 and 14 under root 3. Then I will get m is equal to, wait for a bit, yes, m is equal to 7 under root 3 upon 3. Wait here, and I get one more m, and the second m is 2 under root 3. And we have to write equations of invariant lines, which means y equal to mx. Y equal to 7 under root 3 upon 3x, and here I will write y is equal to 2 under root 3x. So that's our equation. So that's our answer. I hope you get this, what we did. As we get to know that it is passing through the origin, y is equal to mx plus c become y is equal to mx. Then we get x equal to t. You can take any variable like x equal to a, then you will get ma as a y. Okay, I got t comma mt. Then I multiplied the two brackets which are given as m and got the final matrix of m, and then I used it and I got x and y, and then I inserted in y is equal to mx, and through this I got m as the t got cancelled, and the m is used in y is equal to mx to get the equation of invariant lines. Now here the last part. The triangle ABC in the xy plane is transformed by m onto triangle DEF. Let's write it. Triangle ABC is transformed by m onto triangle DEF. Okay. Now I can write formula that determinant of m is equal to the arrow is towards DEF, so I will write area of DEF divided by area of the tail. It means area of ABC. So the question is saying find the area of triangle DEF. Given that the area of triangle DEF is 28 centimeter square, find the area of triangle ABC. Okay, so we will write that area of ABC equal to area of DEF upon modulus determinant m. Okay, now we will find determinant m as a modulus. Okay, so what was m's? This is 7. I wish that you should try to find a determinant of m by yourself. This 7 will get multiplied by 1 upon 2, so here is 7 7 upon 2. Then we will multiply 7 under root 3 by negative 1 upon 2 under root 3. So it become, wait for a bit, it become negative 21 upon 2. So let me write, I got 7 upon 2 minus, wait for a bit, minus 21 upon 2. So it become 7 upon 2 plus 21 upon 2 become 14. So determinant of M is 14. Okay, so area of ABC equal to area of DEF is 28 given and determinant of M is 14. So area of ABC is 2 centimeter square. So that's a solution for the question number 4, and I hope you understand each and everything. If you didn't understand anything, you can ask in the comment section. Inshallah I will reply you, and inshallah we will continue this paper. So thanks for watching the video. Like and subscribe if you can, and we will meet in the next video. Thank you.